In this video, we'll discuss CRA models for fraction multiplication algorithms. We're going to look at the standard algorithm for fraction multiplication. So for our problem, we have 2/3 times 3/4, and our standard algorithm for multiplying fractions, right? You might hear it as the multiply across algorithm, which just means we're multiplying straight across horizontally through the model. Okay, so another way of thinking of that is that we're multiplying the numerators, so 2 times 3, and then we're multiplying the denominators, so this 3 times 4. Okay, so that 2 times 3 would give us 6, and then that 3 times 4 would give us 12. So we're going to look at concrete and representational models to help explain why we can use this algorithm. And we're going to just look at the square area model for this one. I'll do the concrete one first, and then the representational one. Okay, so 2/3 times 3/4 means that we have a group size of 3/4. Okay, so we have 3 parts here, right? And each of these are 1/4 of that whole red square, right? It would take one more to fill up that full area. So we have 3/4. Okay, I know that we can't take thirds by just separating these apart, but to help explain the algorithm, we'll want to, instead of partitioning this entire group of 3/4, we're going to partition each fourth, so each piece within that 3/4. Okay, so if I want 2/3 of this amount, the first thing I need to do is create thirds. So again, rather than partitioning the entire group, I'm going to partition each object in the group. Okay, so each of these fourths is going to be partitioned into 3 equal parts. Okay. So this has 3 equal parts now. This has 3 equal parts. And then our last one has 3 equal parts. Okay. So I want to pause here, because what I've done then, right, so this helps explain why our denominator has changed from fourths to twelfths, right? I originally had a model that was composed of fourths, so 4 equal parts. So I had 4 parts that were needed to make the whole. Okay. I then partitioned each of these into 3 equally sized parts. So there's 3 here, 3 here, 3 here. And then if we were to make up this whole, right, we would need another 3. Okay. So this, right, instead of having fourths that make up our whole, we now have 4 groups of 3, right, because really what we did was 4 times 3, so you can kind of think of it as switching the order there. We had 4 groups of 3 that would make up the whole, right, because we have this one that's not shown over here. Right, so 4 columns of 3 would make up our whole, which would be 12 equally sized parts. Okay, so since we took each part, and instead of having 1 part, we made 3 parts, what we did was we multiplied the number of parts that we need to make up the whole by 3, or by that denominator in that leading fraction. Okay, so that kind of helps explain why we can just multiply these 2 denominators together to find the product. Okay, because we started with 4 parts to make up the whole. Each was broken into 3 equal parts, each of those 4, which is 4 groups of 3, or 12. Okay. So now I've separated this into thirds, right? But looking at the leading fraction again, I want 2/3 of each of those fourths, right? 2/3 of each column. So I'm going to just expand these break lines just a little bit so we can see them in the video a little bit better. And so each of these columns has 3 equal parts. I want 2 of those 3 equal parts. Right, so we're going to think of just taking, we don't want those bottom ones, right, because that'd be 3/3 of each column, so I just want 2/3 of each column. Okay. So then I want to pause there and look at why we can think of this action as multiplying our numerators, right? I originally just had 3 parts shown, right? That's what the numerator means, is the number of parts that we have. I originally just had these 3 yellow parts shown, right? These full yellow strips, right? 1, 2, 3. Now, instead of having 1 part in each column, right, that leading fraction said I want 2 of those parts in that leading column. So I've doubled the number of parts that I have shown in my model for these black parts. So I went from 3 parts, 3 yellow parts, to now 6, so I've doubled that amount. So this is the action of multiplying our numerators. Okay, so now I started with those 3/4, started with the 3 yellow pieces. I took 2/3 of each of those pieces, or each column, you can think of it in the square model. So now what do I have shown? Well, I have 6 parts that are shown. That's my numerator. And then how many of these parts would it take up to make the whole? Or you can think of what is the name of each of these parts. Right? It would take 12 parts to make up our whole, so that's why we have 12ths there. Okay. So that's our concrete model. For representational model, I'll show just another square model. Okay, so for my starting amount, right, those are 4ths. And I have 3 of those 4ths. Okay. So if I want 2/3 of this entire quantity, right, what we'll do is separate each row, or each column, sorry, into thirds. Okay. So I've separated that into thirds, this into thirds, this into thirds, and sometimes it can be helpful to draw these dotted lines in just so we know that each of these is a 12th of the whole. Okay, so I've separated that into thirds. Each column is separated into thirds, and then I want 2/3 of each column, because then that will give me 2/3 of this entire model. Okay, so I'll just kind of cross shade those with red. So 2/3 of this column, 2/3 of this one, 2/3 of this column. Okay. So then again, looking at my answer, what do I have? I have 6 total parts that have the red marks. That's my numerator. And then again, what is the size of each equal part? Well, it takes 12 to make the whole, so I have 12ths. Okay. So again, in helping to explain this algorithm, right, we want to kind of show that partitioning each object in the group, because that initial partitioning of making thirds helps to explain why we went from 4 parts that needs to make up the whole to 12, right, because we tripled the number of parts in each column here. And then the number of parts that we have in each column, right, went from 3, right, we had 1 in each column previously with the 1/4, and then we doubled that when we multiplied by 2.